Hi, welcome back. This is Professor Ridge, and today's lesson is section 3.3, solving applications, systems of two equations. So again, let's code for word problems. A lot of these are similar to ones we've done before, just now we can use two variables. So let's try a few of these. Okay, let's look at exercise 22 from the book. O-Nuts sells pistachio kernels for $6.50 per pound and almonds for $8 per pound. How much of each type should be used to make a 50-pound mixture that sells for $7.40 per pound? So this is a classic mixture problem, and what I want you to do is start using charts. And so what I do is whenever you have, this is like this mix, when you're doing these things where it's price per pound, so you got a price per pound, and then you times it by number of pounds. And that's going to give you your total worth or cost or total price, whatever it is, whatever words you want to use there. So this equation you're going to write on the top of your chart. So we're going to do price per pound times the number of pounds. Now you can interchange these two columns. And when you multiply those together, the pounds cancel and you just get price, total worth, total cost. I'll say price this time. And then on the side of this chart you're going to put in the things that you're mixing. So we got pistachios and almonds and our mix. And so now this is a good way to organize the information. Pistachios are $6.50 per pound. Almonds are $8 per pound. The mixture, we want it to be $7.40 per pound. We're going to make a 50-pound mixture. And that's all we're given. So now on a row, this top equation gives us the relationship between the boxes in a row. So we're going to use P for the number of pistachios, A for the number of almonds, and then we're going to do $6.50 times P. That's going to be the price that I pay for pistachios. $8 times A. And then $7.40 times 50 is equal to $370. Now, I'm using two equations. Where I'm going to get my equations is the mixture, P plus A, is equal to 50. So that'll be my equation 1. And if I use two variables, I need two equations. So generally in these, if you add these two columns, or two rows, you're going to get the total, the mixture. So P plus A equals the total mixture of 50, and $6.50 P plus $8 A equals the total of $370. Now you can use whatever method you want. Substitution, graphing, elimination. I would suggest not graphing. And just to, I like to do elimination when I set them up this way. And I usually, as just kind of a rule of thumb, not necessarily a hard and fast rule, is I look at the smaller one here. $6.50 is smaller than 8. So I'm going to take equation 1 and times it by the smaller one, 650, and negative. So it's negative 650p, negative 650a equals, now 50 times 650, 6.5, is 325 negative. Now I'm going to take equation 1 and equation 2. So I'm just being lazy, not rewriting an equation 2. I guess for your notes I shouldn't do that. Okay, so I'm going to take 650, negative 650 times equation 1 and get negative 650a, or p, I'm sorry, minus 650a equals 325 negative. Equation 2 I'm leaving alone. So 650p plus 8a, I'm going to put the zeros back in, 370. Remember, that's negative. So I'm going to add those together. The p's cancel. And we get 150a equals 370 minus 325 is 45. Now I'm going to solve this equation. 150. I'm going to divide by $1.50. And that gives me 30 pounds of almonds. Now I need to know how much of each type. So I got 30 almonds, so I go back to equation 1. If A is 30, plug it in. What plus 30 equals 50? 20. So we need to mix 30 pounds of almonds with 20 pounds of pistachios. To get a mixture that's worth $7.40 per pound. Okay? 26. Etch Clean Graphics uses one cleanser that's 25% acid and a second that's 50% acid. How many liters of each should be mixed to get 30 liters of a solution that's 40% acid? Now I write this up a little different than it's probably explained on MyMathLab or from the book. But the way I think of this is I'm going to use this relationship on the top of my box. I'm going to take the amount of solution, the total amount, times the concentration rate. And that's going to equal the amount of pure whatever the concentration rate is talking about. So in this case it's talking about a 50% acid concentration or a 25% acid concentration. So those are the two, 25% and 50. Now if I were to take 10 gallons times 50% acid, that means I got 5 gallons of pure acid, or these are liters actually. If I took 10 liters times 25% of acid, that's going to be 2.5 liters of pure acid. So now my table, make the same table just like the mixture ones. So it's kind of the same idea. So I'm going to put the things that I'm mixing. So I have my solution A, which is the 25% acid solution, solution B, and then my mixture. So let's see, I want a 40% mix. So I only have these two containers, and I need, for whatever reason, I need a 40% acid because 50 is too strong, 25 is not strong enough. So I need to blend the two together to get a 40% to make it just right. So we want 30 liters for this job. And that's all the information given. So we're going to let A be the number of liters of solution A, B be the number of liters solution B. Use the relationship on top to fill out each row. So amount of pure acid is going to be 0.25A. Amount of pure acid for B would be 0.50B. And then 30 times 0.4 is 12 liters. So we got 12 liters of pure acid and then 18 liters of whatever the dilute is, like water probably. Well, it won't be water, but anyway. So let's see. Now I'm using two variables, so just like we did with the other one. If we add the two, if we're mixing them together into the same bowl, we get 30 liters. And then we're going to add these two together to get the amount of pure acid. So the amount of pure acid from the first container plus the amount of acid from the second container. Going to mix it together to get the amount of pure acid in the final mixture, which is 12. And just like I did up there, I'm going to take equation 1 and times it by the smaller, this was 0.25. I'm going to times it by the smaller one, the 0.25. Which is negative 0.25A, negative 0.25B, then 30 times 0.25 is negative 7.5. Equation 2, we leave it alone. Add those equations together. The A's cancel. 0.25B, that's 4.5. Divide both sides by 0.25. So B must be 18. Yep. Okay, so B is 18, and then I look at equation 1. If B is 18, A must be what? We get 30. 12. So how much should we mix? So we need to mix, 12 liters of the 25% solution. Is 25%. With 18 liters of the 50% acid solution. You get a mixture that's 40%, 30 liters of a mixture that's 40% acid. Okay, number 40. Cody's motorboat took 3 hours to make a trip downstream with a 6-mile-per-hour current. The return trip against the same current took 5 hours. Find the speed of the boat in still water. So for these, for distance, I always use this formula. Distance equals rate times time. I write that down. And I kind of do overkill with distance problems. I usually make a chart, a table, and I also make a drawing. Here's my drawing. We're going downstream for 3 hours, and then we're going to return So for this one, I might not do that. And then we also have a current equals 6 miles per hour. So whichever way it's going. So we have, we're going downstream and upstream. Now note that your speed with the current is the speed that you can go with the boat. The actual motor is turning and pushing water past it plus the current. So it's going to be, so if R equals, R is the rate of boat in still water, and C is current, which in this case we know is 6, the speed with the current is going to be equal to R plus C. So the current's pushing you faster. Speed against the current, and it's just straight add or subtract. So against current's R minus C. So we don't know the speed of the boat in still water, but we know that the current is 6. So going downstream, that's going with the current. So that's going to be R plus 6. Going upstream against the current would be R minus 6. The time going downstream was 3 hours. And the time going against the stream took 5 hours. Now our distance, remember distance equals rate times time, so distance is 3R plus 6. Oh, you know what? This, I forgot, this section we want to use two variables. So we'll use D sub 1 and D sub 2. So we use the equation R plus 6. I'm going to move the 3 to the front. Well, doesn't matter. It's D1. R minus 6 times 5 equals D2. And what do we know about the D1 and D2? Since doing a return trip, they're actually the same. So I can erase the subscripts. So it's just D for distance. You know, that's D. Alright, so how do I want to solve this? Substitution and elimination. This one I'm going to do substitution because I got it solved for D. So I'm going to take this D and substitute it into the other equation. And basically we're going to set them equal to each other. So this is the D. So I'm going to take this D, R minus 6 times 5, and plug it in to the top equation. Alright, so distribute the 3, distribute the 5. I'm going to get R by itself. Let's go ahead and do both steps at the same time. Divide by 2, so R is 24. And that's what we were solving for. So the speed of the boat in still water is 24. Now what were these? Miles per hour. So it's 24 miles per hour. Alright, so that concludes the lesson for 3.3. Go to my math lab and do some of the exercises there, and I'll see you next time.